It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, on today's show we rearrange formulas to highlight a variable of interest. So we continue our work from the last lesson where we were solving equations with extra variables, and we're going to apply that idea to working with formulas to highlight a certain variable. So let's get right into it. Try this opening exercise here. Pause the video and solve the equation s equals 180 times n minus 2 for n. So solve the equation for n. That means I need n equals in terms of s. So s is going to be on the other side. So pause and see how you do. There's kind of two paths you could have taken here. Some of you probably started out by applying the distributive property. Here's n. How do I get it alone? Well, I have to get everyone with n on this side and everyone without the n on the other side. So let's add 360. Do I know what s plus 360 is? No, it's s plus 360 equals 180n. Well, I don't care about 180 times n, so I'm going to divide. And I end up with s plus 360 all over 180. That's what n equals. The other option is to think about this using inverse operations. Here's n, I'm subtracting 2 and then multiplying it by 180. So let's work backwards. Let's undo these operations here. Let's divide by 180. So I get s over 180 equals n minus 2. How do I undo n minus 2? I want plain old n. I'm going to add 2 to both sides, which gives me s over 180 plus 2 equals n. That answer is also equivalent to the one we just got, because look, I have s divided by 180, s divided by 180. 360 divided by 180 is 2, so as long as I divide both those by 180, I get a correct answer for what n is equivalent to. So consider a rectangle. Let's probably look at a rectangle. Here's a rectangle here. It's a beautiful one with length L. So I have a length of L and a width of W. Now, if we think about a rectangle, the opposite sides of a rectangle are congruent. So if that's L, this side is also L. My L's, I know, look like that. I use cursive L's, otherwise my L's look like the number 1. So if this side is W, this is congruent to that side, and that's W. Write an equation that relates the perimeter, length, and width of the rectangle. So what's the perimeter of any two-dimensional figure? Well, the perimeter is the total distance around it. If I was to run around this rectangle, how far would I have ran? So the perimeter, well, how many L's are there? There's 2 lengths, and I need to add on 2 widths, L plus W plus L plus W. That's my perimeter formula. Solve this formula for L. Solve for L. So how do I get L all by itself in this equation here? Well, there's L. This 2W has nothing to do with it, so let's subtract it to get rid of it on this right-hand side. Well, I don't care about 2 times L, so let's divide by 2. And we end up with P minus 2W all over 2 equals the length. Not terrible, not too terrible. The area formula for a triangle is area equals 1/2 base times height. So if I have a triangle, the area is 1/2 times the base times the height. Solve for B. So I need to get B all by itself. Well, notice, is there any addition or subtraction on this right-hand side? No. So should I be adding and subtracting anything? No. This 1/2 bothers me. I don't like seeing this 1/2 here. I want to get rid of it. A quick way to get rid of a times 1/2 is to double both sides. Because if you double a half, it goes away and you get a whole. So 2a equals b times h. So to get rid of a 1/3, I'd multiply by 3. To get rid of a 1/5, I'd multiply by 5. It's that idea that fractions and division are closely related. Well, I want to solve for b. What's happening to b? It's being multiplied by h, so let's divide by h. So I get 2a over h equals b. Not too terrible. Find the length of the base when the area is 100 and the height is 20. So if there's normally a follow-up question, you take these numbers and plug them in. The area is 100, 2 times 100. The height is 20, divided by 20. That gives me the base. So this equation, this left-hand side simplifies to 200 divided by 20 is b. So I have b equals 10. So if the height's 20 and the base is 10, you get an area of 100. The volume of a cone, so let's pretend we have a little ice cream cone here. The volume of that cone is 1/3 times pi times r squared times h. Volume equals 1/3 pi r squared h. Express the height of the cone h, so solve for h. Express h equals in terms of the other variables. Well, I don't see any adding or subtracting, so I shouldn't be doing any adding or subtracting. I see a times a third. How do I get rid of a third? Well, if I multiply it by 3, it goes away. Let's triple everything. Triple that side, and it goes away. Express the height, so I'm solving for h here. Here's h. What's happening to it? It's being multiplied by pi, and it's being multiplied by r squared, so let's divide those away. Let's divide that pi and r squared away. So we end up with 3b over pi r squared. That's h. Did I express h? Yes. In terms of the volume and the radius, I did. There's h. Remember, pi is that irrational number, 3.141592, blah, 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 blah. It's the ratio between the diameter, the circumference, and the diameter of a circle. It's that lovely number that you learned about in 7th grade. So I isolated the variable by undoing operations. Find the height of the cone, and the diameter is 8. We got to be careful here. The diameter of this cone is 8, but my formula deals with the radius. This is a little geometry review here. The radius is 4. My radius here is 4. So find the height, 3 times the volume over pi r squared. I took these numbers and plugged them in, but I got sneaky there with the diameter. Sorry, I had to make sure I reviewed a little geometry with you. So I need to do 3 times 67 divided by pi 4 squared. So let's make a fraction. Alpha y equals, enter. 3 times 67. Where's the pi button on this calculator? Look above the division sign. There's the exponent, the caret. There's a little blue pi there, so I'm going to hit second pi times 4 squared. 3.9987, I'm going to say the height of this cone is about 4. The height of that cone is about 4. Not too terrible. Not too terrible. So to get rid of a 1/3, I multiplied by 3. To get rid of a 1/2, I multiplied by 2. To get rid of a 1/6, I'm going to multiply by 6. Let's try a little OYO here. Let's try a little on your own. For each of the following equations, solve for the given variable. So let's pause and see if you can solve these 3 equations here for the given variable. Then check your work with mine. So solve for h. Here's volume equals pi r squared h. How do I get h alone? Well, I don't see any adding or subtracting. I see a bunch of multiplying. How do I undo multiplying? Divide by pi, divide by r squared. Divide by pi, divide by r squared. So volume over pi radius squared equals h. Did I solve for h? I did. Solve for y. So there's y. Everyone with a y has to go on one side. Everyone without a y goes on the other side. So that ax doesn't have a y, so it's gone. Goodbye. by equals c minus ax. Well, I don't care about b times y. I want plain old y, so let's undo the multiplication by dividing. Y equals c minus ax all over b. Did I get y by itself? I did. And finally, solve for m. Get m by itself here. Well, I don't see any adding or subtracting, so that's not an option. But I want to get rid of that 1/2, so let's do times 2. Let's double each side, and then I'll get rid of the 1/2. M times v squared. Well, I want m. How do I undo multiplying? I'm going to divide by that v squared. So 2k over v squared equals m. And that's my solution. We've got one more equation here to work with. A equals p times 1 plus rt. Solve for p. So I want to get p all by itself here. A equals p times 1 plus rt. Well, how many p's are there? Well, it's right there. What's happening to p? It's being multiplied by this chunk. How do I undo multiplying? I'm going to divide. I'm going to divide by that whole chunk there. We have to think about that 1 plus rt as a single unit, because that's going to get me p all by itself. They're being multiplied, so let's divide. A equals p times 1 plus rt. Same equation, but now let's solve for t. Let's get t all by itself. So I don't want to deal with that multiplying by p, so let's divide by p. A over p equals 1 plus rt. Here's t, I got to get it alone, so let's subtract 1. A over p minus 1 equals rt. We're almost there. I don't care about r times t, so let's divide by r, because I want to get t alone. So my final answer appears to be a divided by p minus 1 all over r. It's a nasty answer, but that's what t equals. You could have distributed and you're going to get a similar answer. You could have distributed, you're going to get an answer that looks like a minus p all over pr. That's what your answer is going to look like, but either one is acceptable. Actually, it looks probably cleaner if you did the distribution here by getting that second answer I got there. So hopefully these formulas didn't scare you, but we just need to think about the structure of the equations when my adding and my multiplying. And just remember, there's 3 legal things you can do. You can apply the distributive property, you can use the addition property of equality, or the multiplication property of equality. And that's it. See you in the next video.